So turns out the problem was that, of course, to use anything Android related, you got to run it in the emulator. So that was the thing I was complaining about there. I'm just shaking down a couple other little things. I'll walk through each of these in a second here. Forgot to put primary key on this one because everything needs a primary key. I need to have the artifacts for that guy. Let's see, this one here probably has the right ones. And this guy here should do it. I hadn't used KAPT. Down here, I copied it and it said annotation processor. So I actually pulled in the wrong annotation processor and it only worked for Java code. Now I need the KTX stuff here for the flow support. And what is he complaining about over here now? Well, that's the unit test one. The unit test one can't do that because that's only in the, let's comment him out for a second. And let's try running that test repository again. And still unhappy. So what is he unhappy about now? So it looks like it got to the assertions. Oh, I didn't have the IDs set in these guys. So let me show you what I've done. So I moved all the code up to the instrumented test. I really hadn't planned on going there yet, but because we need to for the database, we're gonna have to do that. So we can use an in-memory database builder, or we could use our normal database builder. The in-memory should be a little faster here. And then I had it added this callback here so that it'll insert the two movies that we're going to check for. Down here, oh, and once again, I didn't do my IDs correctly. And we'll do M2 over here. There we go. Our IDs and our titles. So hopefully those will match now. So I'm just checking to see when I pull the data out, am I doing it right? So inside here, I'm creating a repository, passing the database in, and then doing this type of stuff. So I could actually have a test database that just goes against the database. Let's try that. Test database as an instrumented test, because now we have access to the database. And then instead of hitting the repository, we'll just say database dot movie DAO get movies. And we can test that and see if that works. And then we'll do the same thing with the repository, except we're now adding that extra layer on top for the repository. Same kind of call, but we're just going through the repository this time. Let's test, first of all, the database, see if that's going to work. Hey, that succeeded, yay. So obviously I got the data right that time. And then if we do the test repository, we should see the same results. It should work just as well. There we go. Now this is actually running on an emulator. It's not showing anything interesting right now. So it's like if I have the emulator here, you won't see anything interesting happening with it when I run that. Because it just runs it, boom, it's done. It wasn't trying to bring up a user interface or anything. We'll see some user interface tests a little bit later. Okay, so that takes care of a repository layer that has to be done on the emulator in order to deal with the Android context. That's why it didn't see the application provider and why it wouldn't see this JUnit test. Those only work if you're doing instrumented tests. Okay, so now let's go back over to the unit test side and do what I was actually trying to do before. So in this case, what we're going to do now is try to test the view model. So our view model right now has this create movie call and has a repository get movies. And let's add in a function here for update movie. Repository.save movie. Well, I guess I could rename that to be save over here. Something like that. And this is where we're actually going to pass in a dummy repository. And the dummy repository won't care about the database itself because we're just going to override those functions. So if I have a class mock repository, and he's going to extend movie repository, not passing in a database, and then I can override get movies. And this is going to return a emit list of movie M1, Die Hard, movie M2, Get Smart, something kind of like that. And then we'll do the same kind of thing for save movie, but save movie is not going to do anything there. And now I'm going to do that thing where I was talking about seeing if the functions were actually called. So we're going to have a get movies called and a save movie called. And so this one's going to say get movies called equals true and save movie called equals true. Something kind of like that. So now we've got this mock repository. We should be able to use that from inside of view model. So over here, I'm going to have this be test view model. And what we're going to do is say val repository equals mock repository. So we'll just create that guy. And then val view model equals movie view model, passing in the repository. And now we'll just do this stuff here and see how that works. So repository get movies test, we're going to make sure that those are actually there. Let's take a look to see if the repository had get movies called. And then we can do a repository dot save movie, passing in some movie. And then we can actually do this as well to see if save movie was called. So this little one should test the functionality of our view model by itself. It's not actually using a real database behind the scenes. It's just trying to say, is the view model making the right calls to the things behind the scenes? So this one should run very quickly. And it should run without needing to be inside of a, whoops, there should be a view model here. And it should be able to do this without being inside of an instrumented test. So if we run this now, oh, now we get the test events were not received. Overall setup should be static. It still shouldn't be. JVM static is an annotation you can throw into a Kotlin class to mark it as a static function when it creates the equivalent Java code. And the statics have to be inside a companion object. Not that we really needed that to run anything, but that's actually how it should be. I just forgot to put it in the companion object. So that one worked, and that one worked now. So is it actually going to run the individual ones now? Okay, so now it's okay. Okay, so let's see what we got here. So test view model. Expected. Oh, once again, I'm not putting the IDs in there. M1 and M2. Call me out when I forget to do that, because I'm going to forget to do it 16 more times. Let's try that again. And this should test our view model. And M1. Oh, I got them in the reverse order. Wow. Now, one thing I did do during the break is I came in here and I added in an order by title So I would have a deterministic order when I got this stuff back. But unfortunately, I specified the wrong order inside my test here. It's die hard, then get smart. I think after 54 years, I know how to alphabetize. Let's try that one more time. And boom. So now we got a test for that. So this is letting us try, test out functions trying to mock up stuff behind the scenes. And what we did here is I created an explicit mock. Now we can use some libraries to help with that because it's a very tedious thing. Usually what you just want to do is specify what gets returned and if something was called or not. Those are the things you usually care about when you're mocking things up. So what we can do is, well, let's first of all try moving this mock over and see if that works. It should now. I think it was probably because of that before function. Unfortunately, it gave a really bad message there. There we go. So that worked. Let's, instead of using this explicit mock repository, let's use a library called mock-k. And let me come into here. I did not include him yet. It's a mocking library for Kotlin, version 1.12.0. And let's find the import here. So here he is. And we'll put in 1.12.0 and sync him. And so what this will let us do, if I remember my syntax correctly, is instead of doing the repository this way, I can say mock-k and say movie repository here. And I believe that's all I need to do. So that's going to actually create a class with all the stub information and information to tell us if functions have been called and things like that. I'm still passing it into my movie view model the same way I was doing before, but note that with the movie view model, I'm going to have some trouble if I try running the real application because of trying to pass the data in there, okay? But we'll fix that in a minute when we do some dependency injection. So these are a little bit different now. We're not going to have this get movies called the same way. What we're going to do is we're going to make calls, and then we're going to call something called verify. So I'm going to assert the results here for calling the await item. And let's see, which way am I going about this? I'm going to call verify to check to see, did it in fact call the function that I thought it was going to be calling? And in this case, we're going to verify that we actually called viewModel.movies behind the scene. Actually, not the view model. I want to do repository get movies. So we're going to verify that repository get movies got called when I called viewModel.movies. And we're going to do the same kind of things down here for when I call save movie. I'm going to say verify repository dot save movie, passing in a movie. Let me make a copy of that movie here to save. And we'll say to save. And actually I want to do that from the view model. We're testing the view model. I want to make sure that when the view model save movie is called, it's actually trying to save it in the repository. Okay, so now this will, actually I should have left these other guys in so that we could see what those actually looked like. Get movies called. And one thing that I want to do is I want to make sure when this call happens, I actually return something here. So I'm going to say every call to repository get movies returns that flow that I'd set up inside that mock repository before. So this guy here. just like that. So this is how we're telling that mock that was generated what to do when somebody calls get movies. So if somebody calls get movies, I'm going to return that flow just like I did explicitly. And so I'm going to verify that that was called, and then I'm going to check to see was the actual thing that I told it to send out coming out for viewModel.movies. And let's see if that actually works. Hopefully I got my syntax right on that. And something is not happy. No answer for movie repository get movies. So let's take a look here. Oh, there's the problem. Okay. So let me explain what just happened here. In the view model, it actually calls get movies when the view model is being constructed. So I was putting in that every call too late. What happened inside here is that at this point, get movies was being called, and then I set up the every. If I move this every up in between there, this will work just fine now. So now I can run this. I meant to do this. You can see how this happens. And now save movie, no answer found. Okay. So apparently that's what I need to do. Just run repository save movie any. And let's do that. Okay. But if you couldn't tell, today is the first day that I've been using this Mach-K library. I had been using Mockito before for things, but I would have had to look things up because it's been a while since I've written some Mockito tests. Okay, now it's going to work. It's totally going to work now. There we go. So we got a good test result out of that. So this tells it what to return. This said, I'm not actually returning anything. That's what the just run does. Okay, so that actually does all the work that this mock repository did for us. Basically, everything you're seeing here is done inside that mock that was created. Okay, so now we get to talk about the user interface layer and how to test that. So once again, that's going to have to be up here at the instrumented test layer. So what we want to do inside here is set up some code that's going to create a user interface and then allow us to find things in the user interface, interact with the user interface by clicking on things and checking to see what is currently displayed on the user interface. So there's an API set up for that. And let me grab the imports for him. So I'm going to come and bring these guys in here. And this is going to be for compose testing. And this allows us to create some compose unit tests inside JUnit. And this guy down here is needed for us to be able to call create compose rule. So what we're going to do inside here is create a rule inside JUnit test, which allows us to have a hook into the compose system. So we do that by saying @get :rule, and then say val compose rule is create compose rule. And what this annotation does here by saying get, this just puts the annotation on the getter that's created for this guy. Normally when you're using JUnit, you would have a separate get, you'd be doing it in Java, and you would have a separate getter and a separate setter function. This syntax in Kotlin says the annotation just goes on the getter. If you didn't specify that it's actually going to put it both on the getter and the setter, well, in this case, all there is a getter. So that's just going to do when it generates the Java code, put the annotation on the Java getter for get compose rule. So what this is going to do is give us a handle to create a user interface. So let's just do a real quick little setup here. I'm going to say, give us a test. And we'll say fun test simple compose UI. And parens and a curly brace there. And what we're going to do inside here is take that compose rule and set content on it. So we're actually gonna have a user interface. And this works the same way that we do a set content inside an activity. So inside here, we can do, let's see, what is our compose test? So compose test theme. And then inside there, let's create just a text to put on the screen. So I'm going to say text equals hello. And let's give him a clickable. So let's say modifier dot clickable. And let's have that actually change the text on the screen. So we're going to need to do something kind of like a var text by remember mutable state of. Let's start off as hello like that. Well, not set of, state of. And then, of course, we need to come up here and do our, let's see, the compose runtime remember, compose runtime get value. And that should be, oh, why is he not happy? Oh, it's a var, so we need the set value as well. There we go. So now we have a text that we can use. I can say text is text. And then inside here, text equals goodbye. So when you click it, we'll go goodbye. So a real simple little user interface, just going to have a piece of text on the screen. You tap it, boom, it changes. This will actually see showing up inside the emulator. So I'm going to pull the emulator over here. That way we can take a look at it in a little bit. And now we need to actually interact with it and take a look at it. Let's try to look up parts of the user interface. Now, the way this works in Compose is there's a couple trees that I've been talking about. There's the one tree, which is the actual widgets that we're going to display on the screen. And by that, I mean it's the declaration of the widgets we see on the screen. So in this case, it's going to have some tree elements for the theme and then tree element for this text underneath that. And that's just going to represent text to go on the screen. Compose will take a look at that tree and see if it's changed. If parts of it has changed, it'll only re-render the parts that have actually changed. So in this particular case, if the text has changed, it should re-render that text on the screen. And let's actually let this guy be a Filmax size as well. Okay, so that should just center the text. Yeah, let's try that out, see how that works. So now we got our little user interface. The first tree represents what is actually going to be rendered on the screen. There's a second tree called the semantic tree that goes along with this. And semantics, the word just means meaning, gives you some information about the other tree. And they're basically parallel trees. So nodes in the main tree may have a node in the semantic tree that maps to it. In some cases, the nodes in the semantic tree get kind of rolled up. So if you had a button with several texts, those texts get rolled up automatically. And the semantic tree is used for two things, mainly. One of them is for testing, so you can use that to help look up pieces of information. The other is for accessibility. So if you had a screen reader, it could actually use the semantic tree to get information to read to somebody. And you can add in extra information by making semantic modifiers on things. So I can come in here for the modifier, and I could say semantics, and then inside here, do things like set passing in a key value pair. And the key has to be something like semantics properties dot test tag. Test tag is a useful one because you can add little pieces of information that are notes to help you locate things for testing. That's especially good if the text is going to change on it. If the text doesn't change on something, you can look it up by the text. But if the text changes, like in this case, you may or may not be able to access it by that. So in this case, I'm going to say, let's get the text tag be label, something like that. There also is a shortcut for this one here. Oops, actually, I believe it's, you can just say test tag label. which does this block here for you. It's just a nice little shorthand. So I'd recommend you use just test tag, but it's equivalent to that there. So what that's going to do is add some information inside the semantic tree that you can use to look up things or report to the user. Now, the test tag is not normally something that will be reported to the user. There are other tags you can do, like a role for something to say, is it a button? Is it is it a switch? Is it something else? And that can help the user understand how to interact with it if they can't see it on the screen. So we're going to put this test tag in, and that's going to allow us to look up where that guy is. So I can come down here and I can say compose rule, oops, and I can say on node with tag label. This will go and find that semantic node for the label, matching it up to the node in the tree. So we look this up in the semantic tree, and that tells us the node that's actually in the actual rendering tree that they're going to be using. And then we can say assert text equals, or text contains. I'm going to say text equals, what did I call it? Start with hello. So we're going to start off and say, is it hello? Then what we can do is say perform click. And that will simulate the user clicking on that. And now we can, after that, say, let's check to see if it's goodbye. And do I have an extra curly brace, or where's that curly brace matching up? Oh, I made this mistake earlier when I was testing this guy out. Notice how right now I have these inside the set content, which is really where I don't want it. I'm going to leave it there just so you can see what gets reported, because this actually is something that might happen to you. It happened to me a couple times. Let's do our sync to make sure we pull in everything we need. And now let's try running this. So when we run this, we should see the user interface come up, and we should see some errors come up about this. Now, the user interface might not show because these errors might get triggered. Let's see what happens when it runs. Okay, so that ended up crashing. You'll see that we got an error on the test here. If I click on it, we're going to see up here functions that involve synchronization, assertions, actions, synchronization, assert is selected, blah, 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 cannot be run from the main thread. Did you nest such a function inside one of these guys? Boom, it's exactly what I did. I nested it inside set content. Now, what they're talking about synchronization here is whenever you do some calls like assert something or other, it's going to, first of all, make sure that the user interface is idle. So it's going to make sure that everything has been rendered. It's going to wait until it's stable. It's gone through any type of rendering passes it needs to, and then you can check against it. And that's really useful. Now, there are some ways you can manually synchronize or turn off the synchronization. I'm not going to go into those details, but especially when you're dealing with things like coroutines, and you want to check to see where things are in the state of a coroutine, you can actually set it up so that you can get a frame by frame update of what you're seeing on the screen, and as well as stop at certain locations during your coroutine run. For the most part, you're going to want to use this automatic synchronization so that whenever assert is called, it's going to pause until everything is stable before it actually checks to see what is this thing on the screen. But you can get more fine-grained control on that. So what I'm going to do now is move these where they should be, which is outside of that block. And then we should see if this actually works. Let's go ahead and run him. And there we go. We got a successful run on him. Let's see what happens if that wasn't correct. Well, let's put it down here on the goodbye. So we got our error here. When we click on it, we're going to see inside here, assertion error failed to assist the following. Text equals goodbye X. And then it's going to tell you the semantics of the node that's behind there. So this is information from the semantics tree that helps describe things to you. So the tag that we put on it was label. The text that's currently on the screen is actually goodbye. So this helps you get a little bit more understanding of what's going on underneath there. And it also tells you which actions have been attached to it. Like we attached a click handler to it. Merge descendants means should I gather any children information and pull it up? So if I had a couple different texts inside a button, for example, if merge descendants was true, it would pull those up into the semantic node that represents the button, as opposed to having the button with separate text underneath. There's some good discussions on how the semantic tree works. So if you say compose semantics, not composer, compose. Semantics in compose here. It talks in a lot of detail about the different tree, the UE tree and the semantic tree, and how they're related. And an example they give here is like if you were creating a custom calendar component, if the component itself was you were drawing everything on the screen, kind of like we drew with our game, there's really no indication to the user if they're trying to use a accessibility framework what's selected, for example, in this case. So it'd be a really good idea if you added in extra semantic information to tell, oh, hey, such and such is selected. You know, this is the month of April and the 17th is selected. Just to give them more information so that when they're using some accessibility tools, they can interact with the application. So this was a pretty simple little test. And you'll notice that the way this is structured is actually pretty simple. If we wanted to get a little bit more complex in this, let's create a separate test for it. So we can keep that one. And we'll come up to here. And then inside here, let's make this be a column. And we'll do a modifier dot, fill max size. And then inside here, let's put a couple texts in there. So let's have a label to start with. And so let's make this be text equals name. And modifier fill max size. So it's going to be the label is going to be name. He's not going to be clickable. And then let's do a text equals Scott, which is going to be the actual username, something like that. Material theme dot typography dot, let's have it just be H6. And then up here, we'll have this be like an H4. Why not? Well, no, I want it to be H6 there. We'll make this be an H4. So we'll make the actual name be bigger. Okay, so we have our test tag for the user and test tag for the other thing there. And now what we can do is say, is the label name and is the username Scott? So we can just test that. Let's run him real quick here. And I'm going to actually bring up the emulator so you can actually see that showing up there. And that passed. It went by kind of quickly. Oh, I was centering stuff, wasn't I? So instead of max size, I want to fill max width. And I don't want to center it. Let's run them again. We should see the user interface pop up there. There we go. And notice it goes away really fast. It's just bringing it up, running the test, and then shutting it down. So that seemed to work okay. But we may want to interact with this in a slightly different way. If we have the modifier, and maybe we don't necessarily know exactly what the subcomponents are. Let's do a test tag on this one. Let's call it stuff. We can actually get that node with stuff and then get his children. Or if there's a bunch of nodes with the same tag, we can actually get those as a group too. So we can do something like get stuff and then do on children, which will let us walk through the children or on children at a certain index. So if I wanted to go with on child at 0, assert text equals name, and child at 1, test equals Scott. I could do something like that. Or I could do on children to get all of the children. And then get individual children out of that, do things with. I can also do a filter with some kind of matching thing. So we can do something like, I got to get my cheat sheet that I'll show you in a second here. Let's say is heading. And we can actually set these up here. So we'll do semantics. So this label here is actually being marked as a heading. So I could filter through and say, just get me the ones that are headings. So we'll go to Jetpack Compose Semantics. There we go, Semantics and Compose. There is a cheat sheet, little testing cheat sheet over here. And this guy here, you can actually get it as a PDF. And this shows you the different matchers that you can call, like that is heading that I just did. And different types of assertions you can call, like, can I zoom in this? Yeah, it's better. Oh, there we go. So I like assert test equals, for example. Useful little sheet here. So we can do stuff like this, and this will say, just get me the heading. And then I could do a, for each one of those that I care about, do they actually match? So maybe I want to say assert any. So maybe all I care is that one of them actually has text. What did I call it? Name, something like that. So what this is going to do is say, find the stuff node, look at his children, filter them down to only the headings, and make sure that at least one of the headings has a name. So that should work. Let's just try that out real quick and see if that's going to go. Ta-da! Okay, and that worked fantastic. So now that we've done that, let's take a look at actually testing something in the real user interface. So if we went to our main activity, right now we have this movies that takes in the view model. We can mock that view model if we want to. We have the movies here that just takes a list of things to display on the screen. So let's actually try testing the real user interface here. I'm going to start with this guy here. So we're going to pass in a list of movies. We want to just take a look and see, did the user interface come up like we expected it to come up? So we're going to come back to our instrumented test. And let's come in here and say at test, fun, check base movies. And then inside there, what we're going to want to do is do our compose rule set content stuff. One more. Did I get that? Okay, good. I'd match those up. Okay. And so inside here, I'm going to create a list of movies. And we will say list of, and let me just copy that from wherever I've been copying that before. So I have those same movies there. And now what I want to do is go ahead and say movies, passing in those movies to display them on the screen. And is that guy doing yeah, he's doing a fill. Good. And now we actually can take a look and see what got displayed on the screen. So what we expect to see is the word movies in a text and then two texts underneath it, one for each of those titles. So I can say compose rule dot on root. Let's do that. So we'll start at the root. Let's do it for this column here. Let's actually give this column a tag just to make him easier to get to. We'll do a test tag, movies, column. And we'll come back over here and we'll say on node with tag, movie column. That's what I called it, wasn't it? Movies column. There we go. And once we have that, let's take a look at the three things underneath it. So on child at 0. So the first one should just have text movie. Assert text equals movies. I believe it was movies all in uppercase like that. Yeah. And then we can do the same kind of thing for child 1. And he should be Die Hard, I believe. And then we can do the same kind of thing for 2 with Get Smart. And let's see how that looks. And there we go. So we saw the user interface came up with the stuff and the test actually worked correctly. Now, you'll notice that there's some redundancy here on all these guys. We're using Kotlin, so you can go ahead and take advantage of things like, hey, we've got a list of movies here, right? Let's move him out of here. Let's just walk through those. So I can say movies for each indexed. Got an index, got a movie. We can move this in here and say child at index. I'm going to say n+1 movie dot title. I'm saying n+1 because this n starts at 0 in the for each indexed, and we already had a 0 item. And then that'll take care of all the pieces of data inside there. So we're using some data to help drive our test here. And you can actually have data to parameterize tests at a higher level. There's some ways you can have the test take some parameters, and there's an annotation that'll walk through some data. I'm not going to go into that. We're kind of a little tight on time. But this should reduce the amount of code we have to write. Let's take a look, see if it comes up here and tests okay. And boom. So keep in mind, you're running this in Kotlin. You have all the power of the language to do what you want inside your test cases. You don't have to be super explicit. And I want to see when you're doing your assignment, doing things like this so that you're taking advantage of the power of the language there. Now, I believe we can actually do a little bit better on this. And we could do something like with that. And then something like that. And then something like this. I believe this will work. I think you want to be a little careful of this because I'm not sure if this would be okay when we have a click in the middle. So if we tried doing this, I don't know if this perform click would give us trouble if we kind of hung on to this node. We can try it. Let me just try it real quick here. And there's several ways that you can structure this. I just want to give you a couple options here. So these two are very, very similar. The difference is whether you want to use a receiver or not. So in this particular case, the width is just taking an argument and passing it in as this into the body of that lambda. The run takes his receiver and passes it in as this. So it just really depends on which style you want to do. The run is really useful if you're chaining things together. The width is kind of, you can't call it from the middle of a chain. So normally I prefer the run, but width is one that sometimes people like to look at. So let's take a look at these and see if this will work. I'm not positive this is going to work because I don't know if it's going to restructure things after the click. But let's see what it does. Yeah, so you're seeing here that it is, let's see what line it's on that it's complaining about. Oh, it's because I did it after these. That guy sent him to goodbye already. I'll probably have a better chance of running if I don't change it just before I test it. There, that seemed to work. So that'll give you a way to kind of shorten up things a little bit there. We can just say, grab the node, and then once we're underneath that, go ahead and just perform the things we want to perform. And so we can do something similar down here. Where was that? Here he is. Where we grab the movies column. We can either use the width or we can use the run form of it. And you really have the same kind of situation there. So that gets our movies node, then gets these other two nodes there. Both of those should all of these should actually return the same result because we're not actually changing anything this time. Okay, so that worked just fine. So we did this for the base movies. Let's do the same thing passing in the view model. So we can create a view model here. Okay, now this is not accessible right now because we only pulled in Mach for test implementation. We didn't pull it in for Android test implementation. So I'm going to add it in for Android test implementation as well. This will allow us to use it in both situations. So now I should be able to import that and movie view model. View model. Movies. Returns flow, blah, 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 blah. And then we're going to say just run view model, save movie any. And we actually won't need that because I'm not testing that here. We're just concerned about getting this. So what we're going to do now is call that movies that takes in the view model so we can see if the view model one works. So now we don't need to set up this because that's inside our every. And we're just going to pass in the view model. And let's see, we should get the same stuff out of this. Although what I should do is put that movies out where I can actually reuse it. When I'm setting it up and when I'm testing. Okay, let's test if this one works. And what's nice here is that we don't have to be testing all the way down to the database layer. You could if you wanted to, instead of using the actual Mach here, you could be passing the real one down there. Okay, what is he not happy about here? Yeah, so that must be because the mock library is being included in there. It's got some conflicts, it says. So I'd have to take a look at how to do that. So what I'm going to do for right now is just disable that. So we could do, let's use this one as a quick test to see going right down to the real database. So we will do instead of doing a mock view model, we'll do a real view model. And we're going to pass in, we're going to have a real repository. And he needs to have a database. So we had our database up here somewhere, I believe. There he is. And blah, 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 blah. Pass in our real database. And so we don't need to do this because we're actually using a real database now. But I do need my movies so that I can compare. Let's grab that guy. So this test will take a little bit longer to run just because it actually has to do real work. Shouldn't be too bad. Whoops. Oh, I need to resync because I removed that one dependency. But hopefully this will work just fine. Hey, it did, yay. So this guy here is actually passing in the real view model. It's running to the real database, and it's got everything fixed up there. One other little thing I wanted to show you. I'm just going to go ahead and pull the code over because we're running a little tight on time. I set up this version of it to actually use a dependency injection library to set things up for us. So what we did here, I used a library called Coin. This is a Kotlin injection library. And what you need to do for that to work is you first of all create an application class. And the application class extends application inside Android. And what this guy is going to do is he needs to be registered inside the manifest. So in the manifest, at the application level, you say Android name equals the name of that class. That's your application class. Android will automatically instantiate that and keep one instance along with it and run it through its life cycle. Now we're just using this as a place to actually be able to have something to run before any of the activities run. So this onCreate is run, we call start coin, which ends up setting up the modules that we're using to define what we're going to be injecting. So here's a module that we're defining. We're using the module function here and setting up a few things inside of it. First of all, we're setting up a singleton, in this case called calculator logic. When you see the example, this will make more sense. I'm not using the dependency injection in the actual example, but this calculator that you're going to be doing your assignment with has a logic section and a view model. So what I'm doing is setting up a single calculator logic, and that'll be passed in whenever a calculator logic is needed. And then the view model takes that calculator logic as a argument, just like we did in the example we were dealing with. And I'm going to construct it using the view model constructors. This is actually going to manage setting this up as a view model behind the scenes for us, doing the factory setup that I had mentioned. So anytime we need a calculator view model, we'll create an instance of it. And this get says, get some object from the module that matches the argument I need. So here, that's going to grab the calculator logic because he needs a calculator logic. So this will create a view model when we need a view model. And the view model will automatically create his constructor argument, the calculator logic that'll get passed in. So we're using the module to take care of that for us. If we look at the activity, this line is just slightly different than we had before. It used to say by view modules, which was the built-in Android support. This is by view model, which is inside Coin for fetching the view model appropriately. So Coin is taking care of that fetching for us. Everything else stays exactly the same on how we're using our view model. So I just wanted to show that really briefly. It's not too hard to set up a couple pieces. And in this case, we're setting up the pieces we care about. The logic behind the scenes. You could similarly do something with the database to set up the real database behind the scenes like we just did. And then how to get the view model. And that is about as deep as I'd want to go with the dependency injection. There may be some other common objects you need for some common functionality that you might want to do it with. But if you do too many more, it starts to get really hard to debug and figure out what's going on there.